Hello, this is Dr. Lukes, and in this lesson I'm going to just simply go over our review guide for Exam 2. Now first of all, just so you know how this ties into the full course, we're looking right now at course objectives 2 and 4, which say that by the end of the semester you'll be able to select and use computer tools. Okay, so that's one of the things that's important, that you can make a choice of which computer tool is appropriate, to solve chemical engineering problems that require mathematical skills that are solving systems of algebraic equations, linear and nonlinear. Nonlinear will be on test 3. And then performing numerical integration and differentiation. The format is much like what it was on the last test. Part 1 is a written exam. It's closed book, closed notes. You cannot have a calculator or computer on this portion, and you need to turn it in before getting out your computer. Any math that you're required to do will be simple, that you don't really have to have a calculator to do. Part 2, you're going to download from Canvas, and then again at the end submit it on Canvas. This is the computer exam. You'll do it on your own laptop. You are going to need to use Excel and VBA for Excel. This test really, it's a strong emphasis on Excel more than the VBA, but there's some places where VBA is useful. We are not doing Python on this exam, although we have started to introduce it into the homework, but it is not on the exam, so don't panic yet. Now, in order to perform well on the exam, what you should be able to demonstrate to me is that you are able to first use appropriate numerical differentiation formulas, so the forward difference, backward difference, central difference formulas, to estimate first and second derivatives from functions or from data. You do not need to memorize these. If you need them on the written test, the formulas will show up on the test. Otherwise, if it's on the computer test, you have those. They should be saved to your laptop so that you have access to them. Similarly, you should be able to evaluate integrals for functions or from data sets using the trapezoid rule or Simpson's rule. Now remember, a key thing here is that you want to make sure whether or not you've got evenly divided data, or is it not evenly divided. If it's not evenly divided, you're stuck with having to use the trapezoid rule. And then the other thing is you have to have an even number of intervals to use Simpson's rule. So making sure that you have the correct information for the correct rule is a key in making decisions here. Next thing is determine which of these rules is the more appropriate for your numerical integration. We just discussed that. Now remember, things like choosing a more appropriate technique, those are things that I frequently ask on the written exam portion. And things like actually doing the calculations would be more typical for the computer exam. Again, you do not need to have any formulas memorized. If you need them, you'll have access to them during the computer portion of the exam. If you need anything during the written test, it will show up on the exam. Next, you should be able to perform basic matrix arithmetic computations by hand. So this is adding, subtracting, and multiplying, or also multiplying by a scalar, but multiplying two matrices. These are skills you should be able to do by hand. You also should be able to take the determinant of a 2 by 2 or a 3 by 3 matrix by hand. So those would be things that might show up on the written test. With Excel, you should be able to evaluate the determinant of a matrix. There's also a way to find the inverse of a matrix or to multiply two matrices. You should be able to do those in Excel. Solving a system of linear equations, you ought to be able to do that by hand or by Cramer's rule, either by hand or in Excel. This is just one of those skills that you ought to be able to have. If I ask you to do it, it will probably be for a very simple-minded system of equations. If I'm asking you to do it by hand, it might be fairly complex if I ask you to do it in Excel. You should also be able to solve a system of linear equations using inverse matrices. Now, I would not ask you to find an inverse matrix by hand, but if I gave you A and its inverse and asked you to then find the solution to a system of equations with that given information, you ought to be able to do that because it would be multiplying A inverse times B. And that could be done by hand, so it could be on the written test. But this is more likely to be something that you would do with Excel. Then we also had solving systems of linear equations by the Gauss-Seidel technique. You can do this in Excel. You also can set this up to do with Visual Basic for Excel. This really is our successive substitution technique, just kind of expanded. And then finally, the last thing that you ought to be able to demonstrate is that you can record a macro in Excel that will create VBA code that could be then pasted into your own program, or your own code could be added to this. Okay, so that would be something else that is a skill that you ought to be able to demonstrate for this exam. So that is everything that we've done for this test. The things that you might use VBA for is you might use it for numerical integration, definitely. Gauss-Seidel, maybe. Numerical differentiation, maybe. Mostly we used Excel for this test, not getting into the Visual Basic programming so much. So just be prepared to demonstrate your skills on the next exam. I don't think that it'll be all that different in format from the previous exam. There may be a little bit more of the by hand portion, the written portion of the test, just because of the nature of this material. This concludes my review. If you have questions, be sure to come to lead sessions or ask me in class or in office hours. Thank you very much for your time.